Hello, fellow space explorers. Today we're diving into the fascinating world of STEREO, the Solar Terrestrial Relations Observatory. Imagine two spacecraft launched in 2006 on a mission to unlock the sun's secrets. These spacecraft are STEREO A and STEREO B, our robotic emissaries to the heart of our solar system. STEREO A and B are not just any spacecraft, they are like our eyes in the sky, providing us with a three-dimensional view of the sun. Before STEREO, we only saw the sun from a single perspective, Earth's. But STEREO changed all that. By orbiting the sun, one ahead of Earth and one behind, STEREO A and B gave us a revolutionary new perspective. They allowed us to see the sun in all its glory, from its fiery surface to its explosive eruptions. Why is it so important to study the sun, you ask? Well, the sun is not just a giant ball of hot gas. It's a dynamic and powerful force that affects our entire solar system, including us here on Earth. The sun constantly releases bursts of energy and particles into space, known as solar wind. These solar storms can disrupt satellites, communication systems, and even power grids on Earth. That's why understanding the sun's behavior is crucial for protecting our technology and way of life. STEREO's mission was designed to do just that, to study the sun's activity and improve our ability to predict space weather. By observing the sun from two different angles, STEREO aimed to study the structure and evolution of coronal mass ejections, or CMEs, powerful eruptions of plasma from the sun's atmosphere. Understand the mechanisms behind solar flares, sudden bursts of energy from the sun's surface, and investigate the origins of the solar wind and its impact on Earth and other planets. Now let's talk tech. STEREO A and B were equipped with a suite of advanced instruments to observe the sun in unprecedented detail. These instruments included coronagraphs, which blocked out the sun's bright disk, allowing scientists to study the faint corona, the outermost layer of the sun's atmosphere. Heliospheric imagers, wide-field cameras that captured images of the solar wind and CMEs as they traveled through space. And in situ particle and plasma instruments, which measured the properties of the solar wind and energetic particles directly at the spacecraft's location. These instruments worked in perfect harmony, collecting a treasure trove of data that has revolutionized our understanding of the sun and its effects on Earth. Imagine you're trying to understand the shape of a tree. If you only look at it from one side, you'll only see a flat projection, but if you walk around the tree, you'll get a much better understanding of its three-dimensional structure. That's exactly what STEREO did for our understanding of the sun. By observing the sun from two different vantage points, STEREO provided us with a three-dimensional view of solar phenomena for the first time. This stereoscopic vision allowed scientists to track the movement of CMEs through space, determine their speed and direction, and study their evolution in unprecedented detail. It was like having two eyes instead of one, giving us a much clearer picture of the sun's dynamic behavior. Section 5. Solar storms unveiled groundbreaking discoveries. STEREO's unique vantage point and advanced instruments led to a series of groundbreaking discoveries that have transformed our understanding of the sun and its influence on space weather. Some of the key findings include the discovery of a new type of solar eruption called a solar tsunami, a giant wave of hot plasma that can travel across the sun's surface at speeds of up to 1,000 kilometers per second. Additionally, STEREO provided the first ever three-dimensional images of coronal mass ejections, revealing their complex structure and evolution as they travel through space. Another significant discovery was the identification of the source regions of the solar wind, the constant stream of charged particles that flows from the sun's atmosphere. These discoveries have significantly improved our ability to forecast space weather events, giving us more time to prepare for potential disruptions to our technology and infrastructure. Section 6. The perils of space challenges faced by STEREO. Space exploration is never easy, and the STEREO mission was no exception. The spacecraft faced numerous challenges during their long journey through the harsh environment of space. One of the biggest challenges was the intense heat and radiation near the sun. The spacecraft's instruments and electronics had to be specially designed to withstand these extreme conditions. Another challenge was communication with Earth. As the spacecraft moved further away from Earth, the time delay for communication signals increased, making it more difficult to control the spacecraft and receive data. Despite these challenges, the Stereo team persevered, developing innovative solutions to keep the mission going and ensure the continued flow of valuable scientific data. Section 7, Lost and Found, the Saga of Stereo B. In 2014, disaster struck the Stereo mission. Contact was lost with Stereo B after a planned reset of the spacecraft's communication system. Despite months of effort, engineers were unable to re-establish contact. The loss of Stereo B was a significant blow to the mission, but Stereo A continued to operate flawlessly, providing valuable data from its unique vantage point. Then, in 2016, a glimmer of hope emerged. NASA's Deep Space Network detected a faint signal from Stereo B. After careful analysis, engineers confirmed that the signal was indeed from the long-lost spacecraft. While contact with Stereo B was eventually restored, the spacecraft had suffered some damage during its period of silence, and its scientific instruments were no longer operational. Nevertheless, the recovery of Stereo B was a testament to the ingenuity and perseverance of the mission team. Section 8, A Legacy of Knowledge, Stereo's Enduring Impact. Although the Stereo mission has officially ended, its legacy of scientific discovery continues to inspire and inform. The vast amount of data collected by Stereo A and B has provided unprecedented insights into the Sun's behavior and its impact on Earth. Stereo's observations have helped scientists develop more accurate models of space weather, leading to improved forecasts and better protection for our technological infrastructure. Moreover, Stereo's groundbreaking discoveries have inspired a new generation of scientists and engineers to unravel the mysteries of the Sun and its place in our solar system. The Stereo mission may be over, but its impact on our understanding of the Sun will continue to be felt for generations to come. Section 9, To the Sun and Beyond, Inspiring Future Exploration. Stereo's success has paved the way for future missions to study the Sun and its effects on Earth. NASA's Parker Solar Probe, launched in 2018, is currently on a daring mission to touch the Sun's corona, while ESA's Solar Orbiter, launched in 2020, is providing us with unprecedented close-up views of the Sun's poles. These missions, along with others in development, will build upon Stereo's legacy, further advancing our understanding of the Sun and its connection to our planet. The Stereo mission has shown us that by venturing beyond Earth, we can unlock the secrets of our nearest star and gain a deeper understanding of our place in the cosmos. As we continue to explore the universe, the lessons learned from Stereo will guide us on our journey to the Sun and beyond.